I have prepared this content according to the WBSCT syllabus. Now in today's lecture I'm going to cover up to 4.4 sub topic. Remaining topic will be covered in my part 2 lecture. So first topic is process scheduling. So as I have already explained in unit 1 lecture that how multi-program or how multi-processes works. So in a system it might contain more than one processes. So in order to execute those processes, that processes has to have a mechanism that which process has to be executed first and which process will be executed last. That has to be decided by the system, and for that those mechanism which is required by the system, that is known as process scheduling. So process scheduling is nothing but it is an activity of the process manager that handles the removal of the running process from the CPU and the selection of other process on the basis of a particular strategy. So your particular strategy means it's an algorithm, like there is a various of scheduling algorithm which has to be followed by the system. So that is the strategy. Next is CPU and IO burst cycle. So CPU and IO burst cycle is a state of the execution of the process, which means in a process execution it starts with CPU burst and then it goes to the IO burst and then again CPU burst. Likewise, it always follows in the alternating fashion. So CPU burst is when the process is being executed in the CPU, and IO burst is when the CPU is waiting for IO for further execution. So we'll understand this concept with the help of simple example. Whenever we give some command, that is nothing but it is a program, right? So in a program, suppose we are giving a command to the system to add two numbers. Suppose let us say we have 2 plus 2. So ultimately it has to calculate and it has to give me 4. So whenever this command received by the system, this 2 is input by the user. These two numbers are input by the user. So these 2 and 2 which is given, which is taken from the user, that has to be processed and that has to be calculated, and then resultant has to be given to the user. So here is processing part and here is input output part, where input is taken from the user and at the same time it is being processed and then it is giving us output. So here IO burst and CPU burst is doing this part of job. So this is nothing but CPU and IO burst cycle. Next is primitive and non-primitive scheduling. As I have already discussed, whenever a system has more than one process, that all the process in a system has to be managed by the system. So that managing of the process is known as process scheduling, and that scheduling can be done in two ways, that is primitive and non-primitive. So let us have a look how primitive and non-primitive is working. So in primitive scheduling, primitive means to halt the execution and non-primitive means to not to halt the execution. Like for example, if we have process 1 and process 2, and process 1 enters into the execution, okay, by the CPU. So in between of this execution, if P2 wants to enter and start its execution, then system can allow this P2 for its execution even though P1 is not yet finished. But in case of non-primitive, this mechanism is cannot be considered. Like if P1 and P2 both processes wants to enter, first it has to finish P1 and then only CPU will allocate for P2. So this is overall picture of primitive and non-primitive scheduling. Now we will learn scheduling algorithm. So first one is FCFS, that is first come first serve. So by the term itself it says that when the process which comes first, that will be executed first, and the process which comes last, that will be executed last. So this is the meaning of first come first serve. So let us have a look. FCFS is the simplest scheduling algorithm. It is also known as FIFO, first in first out. Whichever process will be executed first, that will be executed, and then that the resultant has to be given first. So that is FIFO, first in first out. So let us understand with this given net chat. So here given process are P1, P2, P3 and P4, and at the same time its corresponding burst time is 21, 3, 6 and 2. So in the chart we have seen that process P1 came into the ready queue, and then it has to be executed first. So at arrival time 0, P1 came and then it start execution till the time 21. So burst time is nothing but it's the time for its execution. So process P1, whenever it will execute, it will take 21 unit of time for its execution. So that is the meaning of burst time. Okay, so P1 comes in and then it starts from 0 unit of time up to the 21. Next P2 start from 21 unit of time up to the and take 3 unit of time for its execution, becomes 21 plus 3 gives you 24. Next P3, it has 6 unit of time for its execution, so it comes in the time unit of 24 and then start execution with the 6 unit of time and gives you 30. And last one comes P4 with the execution time 2 unit of time and give you 32. So this is overall scheduling algorithm of FCFS, first come first serve. Next scheduling algorithm is shortest job first, SJF. Basically SJF has two part, that is non-primitive and primitive SJF. So as we have already learned what is preemption and non-preemption. So in case of non-preemption, once the process is taken into consideration for its execution, it cannot be taken out. So in case of primitive SJF, that can be done. Once process is in execution, in between we can hold that process and then we can execute other process in between. Now we'll see how this non-preemption SJF works with the help of this NetJet. So we are given 4 processes, P1, P2, P3 and P4 with its corresponding arrival time and burst time. So at time 0, arrival time 0.0, P1 arrives with its execution time 7 unit of time. So it start execution from 0 up to 7. After execution of P1, we'll see among the processes P2, P3 and P4 which processes requires minimum amount of time. So as the name suggests, shortest job first. That means we have to see the shortest job which requires shortest amount of time. That means from this clearly we can say that P3 requires only 1 unit of time. So therefore P3 will be executed from unit time 7 to 8. So therefore its completion time will be 8 unit of time. Next, among remaining 2 processes P2 and P4, we have same unit 4 and 4. So in this case we can decide which process is to be executed first with the help of arrival time. That means P2 has arrival time 2.0 and P4 has arrival time 5.0. So therefore P2 will be executed first and then P4 will be executed last. So therefore after execution of P2, time unit will be 8 plus 4, that is 12 unit of time. And then similarly for P4 with the 4 unit, that is 12 plus 4 is 16 unit of time. Next we'll see preemptive SJF. So as I've already discussed, meaning of preemption means we can halt the execution of the process which is being currently executing. So let us see how it works with the help of this NetJet. Again the same thing, process P1, P2, P3, P4 are given with its arrival time and its burst time. So first P1 arrives at time 0. So P1 comes in and starts its execution. But here it executes till the time 2. So remains what? 5. So why we have used 2 unit of time? Because at time 2 P2 arrives here. So for that reason we have used only 2 unit of time from time 7. Since P1 requires burst time is 7, its execution time is 7, but we can use only 2 unit of time, because at 2 unit of time P2 arrives for its execution. So since we can halt the process which is being currently executing, that is the meaning of preemption. So this is how preemptive SJF works. Next, after P1 with the 2 unit of time, P2 arrives and then it again start its execution with the 2 2 unit of time, remains 2 for process P2. Why? Because at time 4 P3 arrives, so therefore it can use only 2 unit of time. So after executing P2 at time unit of P4, time unit 4, P3 arrives and then it start its execution. So it execute its process with the time unit of 1, so becomes 5. 4 plus 1 is 5. After P3, we are left out with 3 processes, P1, P2 and P4 to be executed with the unit of 5, 2 and 4. So among these, which one is smaller, which one is shortest job? So since we are dealing with the shortest job first, so therefore we have to see which job requires a small amount of time for its execution. So among these 3, we can clearly see P2 requires only 2 unit of time. So therefore P2 comes in and start its execution, and then it becomes 5 plus 2 is 7. Next, after execution of P2, we are left out with P1 and P4, since P1 has 5 unit of time and P4 has 4 unit of time. So therefore we will start executing P4. So becomes 7 plus 4 is 11, and last one, P1 will be executed with 5 unit of time, that is 16 unit of time is its completion for its execution of the process. So this is all about shortest job first for its non-preemption SJF and preemption SJF. Next scheduling is round robin. So in round robin scheduling algorithm, each process is being assigned to a fixed slot of time or a cyclic way. So here we have considered time quantum as 5. So we have to use for 5 milliseconds for each processes for its execution. So let us see how it works. So here first P1 arrives and then P2, P3, P4 with its burst time 21, 3, 6 and 2. So at time arrival 0, P1 comes in with the 21 unit of time, that is its execution time, but we can use only 5 unit of time for its execution. So we have to use 5 unit of time for P1, remains what? 16. So 16 unit of time is still left for the process P1. So next P2 comes in and then it start its execution. Since P2 requires only 3 unit of time, our restriction is 5 unit of time. So 3 is less than 5, so therefore we can include whole execution time of P2. So therefore 5 plus 3 gives you 8 after execution of P2. Next P3 comes in. So this P2 executed all the unit of time, so remains 0. Next P3 comes in and start its execution with the 6 unit of time, but here we can use only 5 unit of time, so remains what? It is still require 1 unit of time to be executed later on. So P3 comes in and start its execution with the 5 unit of time, that means 8 plus 5 is 13. Next P4 comes in, then it requires only 2 unit of time, again the same thing as we have seen this cases in P2. So therefore 2 is less than 5, so therefore it can use whole unit of execution. So therefore when after execution of P4, it becomes 13 plus 2 unit of time, which is 15. After P4 execution, again P1 comes in. So P1 has already used 5 unit of time, so it is still have 16 unit of time to be executed. So therefore if you use 5 unit of time from this 16, remains what? 11. So after execution of P1, here you have used 20 unit of time. Then after P1, which process is left? P3 is left with the 1 unit of time. So therefore after execution of P3, it can use 1 unit of time, so therefore it becomes 21 unit of time for its completion of the process. After 21 unit of time, again we go back to P1. Now only process P1 left. All the processes have completed all the processes. So next P1 with the 5 unit of time remains what? 6. So with the 5 unit of time, 21 plus 5, 26. And then again P1 comes in with the 5 unit of time, remains what? 1. So 26 plus 5 gives you 31. And then 31 plus last 1 unit, 32. So this is all about round robin. So this is how it works. Next is priority scheduling. As the name suggests, it will give priority to the process. So here you can see all the process has their own priority. So your highest priority process is P2. Why? Because it has 1. It has valued 1, so therefore we can treat it as a high priority process. So let us see how it works. Again the same thing, processes are given with its burst time. So with the help of NatChat we'll see how it works. So at time arrival 0, P2 comes in and it requires 3 units of time for its execution. So first we are executing process P2. Why? Because it has highest priority. So therefore it starts its execution with 3 units of time. So after completion of P2, second highest priority is P1. So therefore we'll start executing process P1 with its burst time 21 unit of time. So becomes 24. After P1 we can see 3. That means P4 has the third highest priority. So therefore P4 will execute with its burst time 2 unit of time. So therefore 26. And last one P3 with its burst time 6, that is 26 plus 6 is 32. So this is all about priority scheduling. So next is multi-level. So in this multi-level conception, all the processes are being categorized into certain category according to their priority. So till now what we have seen is, we have seen that all the processes are kept in ready queue. Suppose let us say we have 3 processes, P1, P2 and P3, which are being kept in ready queue. So whenever it want to execute its execution, it was pulled out from this ready queue and then given to CPU for its execution. So this was the picture till now we have seen. So in this case, in this multi-level scheme, all this processor, all the P1, P2 suppose are being kept in system processes according to their priority. Next P3 might have been kept in interactive processes. So this is how it will categorize all these processes and then it will start its execution according to the need. So this system process might use any scheduling algorithm. It might use round robin, it might use FCFS and so on. So this second highest priority, it also can use any of the scheduling algorithm and so on and so forth. So this is how multi-level works.